Good morning, class. All right, so today we are continuing to learn about four-sided figures, okay? And we're learning more about parallelograms, okay? And we're going to see some rules about how we can determine the angles of parallelograms. All right, so I want you to open your textbooks, and we're looking at page 69 together, okay? So this is our parallelogram on page 69, and we're going to do this activity together, okay? So it's telling us to trace and cut out the parallelogram, and if you want to, you can do that in the textbook, but I've sent home this sheet of paper for you. Oh, and that's upside down, but this is what it looks like. All right, and what you can do is you can just cut out this middle shape, okay? We'll use that for you guys, so you can cut that out. Make sure you don't lose these two, but cut this shape out so that you can have your parallelogram, just like I do right here, okay? And I've labeled my corners just so we can see. We have A, B, C, and D, okay? And what it's asking us to do is cut the parallelogram. So grab your pair of scissors and cut it. So I'm cutting it just like they did. I'm gonna make a squiggly line. So now my parallelogram is cut in half. And now I'm going to match my lines, okay? So I'm taking B and matching it with D, okay? So here's B. We're gonna flip it around to match it with D. And would you look at that? So this proves our rule that the opposite angles of a parallelogram are equal, okay? So we have angles A and C, and B and D, okay? And here's where we got them. You remember, A is here, and C is here, and B is here, and D is here. So if I flip my parallelogram around, that's the angles that line up, okay? So that's how we see that across, the angles across from each other are equal. So we're going to take a minute and we're going to write that rule down. So you can continue on with the note that we started yesterday. We're going to call it Parallelogram Rules. Okay, and the first rule that we've learned together is, and it's in the speech bubble on page 69, the opposite angles of a parallelogram are equal. Okay, so there is our first rule. And you can see that on your anchor chart right here. Opposite angles of a parallelogram are equal. And it's got a little diagram here so you can see a little bit more clearly too. Okay, so that is our first rule of a parallelogram. So one more look at that. So if angle A ends up being 40 degrees, say, then angle C is also going to be 40 degrees. Okay, because they match each other. All right, so let's flip the page. Okay, and we're still working with our cut shape that we have, so I hope you still have yours out. And let's look at number 2. This is showing us another rule about parallelograms. Okay, so we have our cut shapes, and now all we're doing is we're kind of flipping it like this so that they face away from each other, so that our squiggly edges are out. And I'm going to turn around so you can still see the letters. Okay, because we have A and D here now, and C and B. So this tells us that this forms a straight line, right? And so does this. And so I got them from up here, and I just flipped them down. And when you do that, you can see that it makes a straight line. So A and D and B and C equals a straight line. So that's telling us that the pair of angles between two parallel sides add up to 180 degrees. So A and D together add up to 180 degrees. And we saw that because when you flip them, it forms a straight line. Okay, and same with B and C. B and C together add up to 180 degrees. Okay, and we can see that again with our straight line. And let's see, I have a fresh parallelogram here, and I'm going to cut it this way this time, just like the textbook does. Okay, and you can see that we can switch it this way too. Okay, and that means that C and D, so like the top half of our parallelogram, also form a straight line. So C and D can be paired up to add up to 180 degrees. And A and B also form a straight line. So they can be paired together to add up to 180 degrees as well. Okay, so that's the other way that works. So it works both ways. Like you can group these two together, or these two together, or these two together, or these two together. Okay, and that's our rule for pairs of angles that are next to each other. Okay, so let's write that rule down on the board as well. That's the second speech bubble. Okay, each pair of angles between two parallel lines okay, sides, sorry. Between two parallel sides, add up to 180 degrees. Okay, so that is our second rule about parallelograms, and we also have that on our anchor chart. Okay, so you can see I've circled A and C together here, and they add up to 180, but it also works for A and D, and C and D, and B and D. Okay, because they're paired together between the two parallel lines. Okay, so let's look at some examples together and continue to see how this is true. But before we look at our examples, I'm going to show you a rule about rhombuses. So we're going to switch to a piece of graph paper. So find your next pair of square graph paper and get it out. And we are going to draw a rhombus together because I want to show you what happens to a rhombus. So I'm making my rhombus this big. Okay, we have 4 down and 2 to the side. And we do that all the way around. And that's my rhombus. Okay, so I'm gonna fill my lines in for you guys. So you can see my rhombus. And then I'm actually gonna cut this out, okay? So take a moment, pause the video if you need to so that you can do this too. Okay, so trace your rhombus. You can make it the same size as mine or smaller if you'd like. Just make sure all of the sides are an even length. And then we're gonna cut it out together. Okay. Okay. So here's my rhombus. And I wanted to show you guys that we can fold a rhombus in half to form a triangle. And what type of triangle is this? This is actually an isosceles triangle, which means that these two sides are the same, okay? And we will talk about this more in just a moment, but it's important to note that, so our rhombus rule is, of course, that these angles are going to be the same and these angles are going to be the same, but also when we fold it in half, this angle is the same as this angle because it's an isosceles triangle, okay? Or 2 isosceles triangles, really. Okay, so let's look at our textbook and look at these examples. So number 3 gives us an angle of 80 degrees and it's asking us for the angle across from it. So we can look at our rule and see that the opposite angles of a parallelogram are equal. So we know that number 3 is 80 degrees, okay? Because it's across from the angle that's given. So that's angle X equals 80 degrees. Okay? You see that? Okay, so now we're given 2 angles beside each other, and we're given 120 degrees and asked to find y. So now we can use our rule that the pair of angles between 2 parallel sides add up to 180 degrees, because this is a pair of angles between these 2 parallel sides. Okay, so we're going to do 180 take away 120 to give us 60 degrees. Okay, and that's number 2. So do you see how that works? We used a rule about them being paired together to add up to 180. All right, and we're going to do the same with Z, because these angles are right next to each other too, which means that they form a pair of angles between these parallel lines. Okay, so we'll do 180 minus 115, which is going to give us 65 degrees. Okay, so that is number 3. Okay, so that's us applying our rules to find the unknown angles. So now let's look at question number 4 together. So this question tells us that all of these are rhombuses, okay, which is important because we're going to see what happens with this in just a moment, okay? But first, let's start with X. Okay, and we see that we're given the angle that's across from it. So we can just use our rule number 1. The opposite angles are equal, so it's also 60 degrees. Okay? So Y, we're going to use rule number 2 again, because being a rhombus doesn't change the fact that it's a parallelogram, because a rhombus is a parallelogram. So we can use our rule that the pair of angles between 2 parallel sides add up to 180 degrees. So we're going to do 180 minus 130 degrees, and that's going to give us 50 degrees. Okay, so that is Y. Okay, so now this one, at first glance you might think, oh, this one looks a little trickier, because how are we supposed to find Z? Well, this is where we can remember that our rhombus is like having 2 isosceles triangles. So if I were to take this and fold it in half, what type of triangle is it? We remember it's an isosceles triangle. And isosceles triangles, our rule is that the 2 angles across from the equal sides are equal. Okay, so these 2 angles are equal because they're across from the equal sides. So that tells us that Z is 55 degrees, because it's the same as the one given. Okay, do you see how that works? So a rhombus makes 2 isosceles triangles that point away from each other, okay? Which means the equal sides are obviously the outside sides, because they're forming the sides of the rhombus, okay? So we can use that to understand that we can make it into a triangle and use an isosceles triangle rule to form our angle. Okay, so that's the last rule for a rhombus. All right. And that is today's lesson. So we've got 2 important rules to use and something to remember about our rhombus. Just rhombuses, mind you. Remember that rhombuses have 4 equal side lengths, okay? And that's why it works that we can fold it in half, okay? So now it's your turn. Please complete exercise 45 and 46 for today if you haven't already worked on 45. All right?